Hi everyone, I wanted to do a quick video on how to create a time series for the graphs you have to make this week. So you'll notice that, I'll go here real quick, right? When you copy your data from the BioPack software, let's say we're using the clinch release cycles as our example, you're approximating where 1 second prior to the first clench would be, in addition to 1 second after the last clench is released. So in this example, Dane was the one who was squeezing the hand dynamometer. So we have 4 cycles that land within approximately, right, 1 to 17 seconds, which would be 16 seconds for the entire window. Now, when you highlight and copy your wave data, the time data, it does not get inserted into Excel. So what you have to do is for the all cycles, if we're doing the clench release or the maximal contraction, what you have to do is add a time series. And the way you're going to do that is if we just have this set up, right, you click on the column that has the EMG data in it, and you're just going to insert another column to the left, and we're going to call this time. Okay. What we can do from here is we know that you're going to be starting at 1 second, right? Or at least that's where your collection area starts. And you're going to be going through 16 seconds of time total. So if we use the number of cells that have been collected in this data series, which is really long, but I know that this series stops at 8,080. Okay, and you can figure out what cell number this is if you scroll all the way to the bottom of your data set. Sorry for any of you who get motion sickness by looking at the computer screen. But you can see this row here, 8,080 is where the last set of data is. So if I scroll all the way back up, I can create a formula that says I want to know, right, how many frames or how many of these cells exist from 880, and then we also have to remember we need to subtract, right, these first 2 cells here. So we subtract by 2, and then we say I want to divide that. So this would be total number of frames that have, viable data, and then we divide that by the amount of seconds that elapsed during our trial, which we said was 16 seconds, at least for Dane's example. Yours might be different if you have more peaks, right, or more cycles of squeeze and release. So this is going to give us how many frames should exist, or how many cells, right, will take up 1 second. In this case, we've got about 505 frames per second. And then we can figure out at what unit we're going to be increasing our time per cell. So that would be looking for how many seconds, right, increase per frame or per cell increase. And the way we can calculate this is we can say within 1 second, I know that there are 504 frames. So this is going to give me an increase of approximately 0.002 seconds each time we increase a cell value. Okay, and then we can use this value to calculate our time series. So if we put equals, and we know we're starting at this cell above, right? So we can put a cell reference for that, and then we're just going to add this little time frame here. Okay, and now when you are copying a particular formula, you have to freeze certain areas. So we want this cell reference to stay the same as we're copying downwards. The way that we can do this is by adding a $ between the column reference and the row reference. And so then if I press enter, I'm going to reformulate this column to read to the third decimal place. And then what I can do from here is just, you can double click, so this little green box, if you hover over it, you'll get a black plus sign icon. You can either double click or you can click and drag. I think because the data set is so large, double clicking, it'll autofill all the way down to the bottom of your data set. So just to show you, you see these time increases from 0 to almost 17 seconds, which is basically the time frame, right, that was shown 1 to 17 seconds in our BioPack program. Okay, so with creating a time series, you then should be able to format your scatter plot. So I should have stayed down at the bottom. But you can highlight all of this data then 2 hours later. We'll get there someday. Again, I'm sorry for those of you who get motion sickness when you look at a computer screen that you're not controlling. Right, we scroll down to the bottom of our data. We highlight all of this information. Okay, and then I would recommend you scroll back up to the top. That way your graph shows up here. But you'll do insert, and then we're going to do a scatter plot with smooth lines. Okay, and then you'll notice something like this pops up, and you'll see that this y-axis, right, is representative of the force data because it closely matches the values that people were able, or that at least Dane was able to get through each cycle. So the way that we can create a dual axis or dual y-axis is if we click on this time series down here, or if you double click on it, actually, it should bring up a toolbar on the right. And I don't know why it's not doing it right now. There we go. Okay, so if you see this orange axis I clicked on, it says it's the primary axis. So this is the axis that's going to show up on the left-hand side of your graph. If I click on this blue series, the EMG data, I can change it to read secondary axis, and then the units of my secondary axis will show up on the right of my chart. Okay, so then you can, when you're adding your axes titles, there should be a primary vertical axis label as well as a secondary vertical axis label, right? And then that's how you can identify each of these axes accordingly. Okay, so hopefully that helps. This process that you do to create the time series for the clench release cycles is going to be the same process you use for the maximum contraction cycles. The only difference is the number of seconds that you're going to be referring to. So in this situation, Dane took up about 26 seconds of a maximal contraction. So if yours is 15 seconds, right, you would change this to 15 in order to calculate the increase. But as you can see, 0.002 should be generally the same, right, based on the capturing rate that we have. So if you wanted to just use a 0.002 reference as your increase, instead of using this reference, that would also work and should give you at least close to what the series or the time series should reflect. So hopefully that helps you guys out when you're making your graphs. And then if you have any questions, feel free to ask during lab.